Welcome to operating system class. Now, today is lecture 3 and we will learn PCB process. We will learn about process. What do you mean by a process? What are different states of process and also process schedulers. Now, the definition first of all, we need to understand the difference between a process and a program. Or we can say that a process is a program in execution. Whenever a program is executed, it is known as process. For example, when we write a program in C or C++ and compile it, the compiler creates binary code. The original code and binary code are both programs. What is binary code? Is a combination of 0 and 1. So when we actually run the binary code, then we term it as a process. So with this we come to the formal definition of process. A process is an active entity as opposed to a program, which is considered to be a passive entity. A single program can create many processes when run multiple times. For example, when we open a .exe or binary file multiple times, multiple instances begin. Multiple instances means several copy of the same application, or we say multiple processes are created. So we can say a process is basically a program in execution. The execution of a process must progress in a sequential fashion. A process is defined as an entity which represents the basic unit of work to be implemented in the system. This is the formal definition of process. Now, process concept. We can say that an operating system, it executes a variety of programs. There are different types of program. One is batch system, another is time sharing system. In batch system, we submit or users submit different jobs together in a batch, and in time sharing system, users program or task, they share the same slot or the same processor. Now in the books you will find the term job and process almost interchangeably. Somewhere you will find job, somewhere you will find process, and both the processes mean the same. So here again we learned that a process is having or it contains a program in execution. Execution must be in sequential fashion. So what are the different process? What includes a process? Includes program counter, stack, and data system. Also we can say the process has different attribute. First one is process ID. Process ID, a unique identifier assigned by the operating system. Just like in case of student database, student roll number is a unique key. Similarly, in a process concept, process ID is a unique identifier. Also the different process states are there. Soon we will learn about different process states. Then CPU registers. What are CPU registers? They are like program counter. CPU registers must be saved and restored when a process is swapped in and out of the CPU. Then accounts information. It keeps, or a process has accounts information, how many files are open, how many instances are open. Different types of information is kept under account information. Then IO status information. IO is input output. For example, devices allocated to a process how many devices are allocated to a process, how many files are open. That information falls under category IO status information. The next is CPU scheduling information. But CPU scheduling information, for example, priority. Different processes may have different priority. For example, a short process may be assigned a lower priority in a one type of in a particular type of job scheduling algorithm, which you will learn later, which is also called shortest job first. In shortest job serve, what we need to do, we need to give the priority to the shortest job. So CPU scheduling information, it keeps the information about the schedule of the CPU. Now, process in memory. Process in memory, what does it contains? There are different types of information. One is stack, then heap, data, text. Stack, heap, data, text. This is the representation of a process in memory. Now we learn about the component and a description of stack. The process stack contains the temporary data such as method, functions, parameters, and it return addresses and local variable. Then heap. This is a dynamically allocated memory to a process during its runtime. Whenever in C, I think all of you have done memory allocation, dynamic memory allocation. There you must have learned about heap. So what is a heap? This is a dynamically allocated memory to a process during its runtime. Then text. This includes the current activity represented by the value of the program counter and the contents of the processor's register. Then data. This section contains the global and static variable. Data contains global as well as static variable. These are the different components. Now we come to process states. What are the different process states? First of all, when the process is created, it is termed as new. What is new? New is newly created process or being created process. Second one is ready, or we can say that running. Instruction, actually this slide we have not kept it sequentially, but generally when the ready process, okay, it's fine that after a process in new state, then it comes to running state. What is running state? The process which is currently being executed in the CPU is called running state. Only one processor at a time can be under execution in a single processor. Then waiting. Waiting, when a process requests IO access, it is in the waiting state. These are different types of state. Then there is ready state. The process is waiting to be assigned to a processor. After creation, process moves to a ready queue or ready state. That is, the process is ready for execution. As soon as the processor it completes the execution of other processes, it will allocate the process, or it will choose one process within the ready queue, from the ready queue rather. Then terminated. Terminated means the process has completed its execution. Also, here it is not written, there are two more process states, though they are not considered as primary process states, but they are still there. There is suspended ready. When the ready queue becomes full, some processes are moved to suspended ready queue. What is suspended block? When waiting queue becomes full, then the process has to wait. It cannot be inserted into queue unless and until the queue or one of the slots of the queue becomes empty. This is the diagrammatic representation of the process state. So in the process state we can see that from the new process it is running to new to ready, and then from ready to running state the process keep on changing the state, the new state to ready state, and then ready state to running state. The process keep on changing its state. Then when the new is admitted or when it is allocated the queue, then it went to ready queue for when it is ready for execution. Also from running state we can see that the process comes back to ready state. How it happens? It can happen whenever an interrupt occur. What is interrupt? It stops the execution of the process. Also you can state that running to waiting. Whenever an IO or event wait occurs, the process changes its state from running state to waiting state. In some scheduling algorithm where the priority is taken under consideration or the execution time is kept under consideration, then also the process switches its state from running state to waiting state, and then again after the event completion or input output it changes its state to ready state, and then from ready state there is scheduler dispatch. Soon you will learn about the scheduler in next classes. With the help of scheduler dispatch it changes its state to running state, and at the end after the execution is completed it changes its state from running to terminated state. It means the process has successfully completed its execution. Now we come to process control block, PCB. What is process control block? Process control block is where there are what are the informations that are related to process control block? Process state, process counter, CPU registers, CPU scheduling information, memory management information, account information, IO status information. So while creating a process, whenever we create a process, then whenever we create a process there is a process state. A process state is allocated. The operating system it performs several operations. To identify these processes it must identify each process, hence it assigns a process identification number, a unique number to each of the processes. As the operating system supports multi-programming, it needs to keep track of all the processes. For this task, the process control block is used to track the process execution state. Each block of memory contains information about the process state, program counter, stack pointer, status of opened file, scheduling algorithm, etc. All this information is required and must be saved when the process is switched from one state to another. When the process made transitions from one state to another, the operating system must update information in the processor's PCB. So we can say that PCB contains information about the processes, that is registers, quantum, priority, etc. The process table in an array of PCB That means logically contains a PCB for all the current processes in the system. This is a diagram, again a diagrammatic representation of PCB. We can say the process state, process number, process state, process number, program counter, register, then registers, memory limit, list of open files, etc. This is a representation of process control block. We have already discussed the process ID. What is process ID? We have already learned. And then there's a state, pointer, priority. These are different things about process control block. What is a pointer? Let me explain one by one field. Hope all of you have seen. What is pointer? It is a stack pointer which is required to be saved when the process is switched from one state to another to retain the current position of the process. This is called pointer. Stack pointer, because we maintain a stack, so there is a pointer. We called it stack pointer. Process state. What is state? It is called process state. It stores the respective state of the process. In earlier slide you have learned the different process states: ready, then running, terminated. These are the different process states. Then there is one of the field which is not shown here is process number. Every process is assigned with unique ID, which is, we can say, process number, PID, process ID, which stores the process identifier. It uniquely identifies one process from another process, just like I have told earlier that in a student database, student roll number identifies one student from another student with the help of roll number, although both can have same name, both can have similar feature. Then there is register. These are the CPU register, which include accumulators, base, register and general purpose registers. Then also we say input output information. Input output information, this include the list of files opens for a process. Then there is accounting information, also memory limit. This field contains the information about memory management system used by operating system. This may include page table, segment table, all of things which you will learn in next classes maybe. So these are the different information about process control block. This is the diagrammatic representation of CPU switch from process to process. How one process executes or changes state from process P0 to process P1, like it saves the state in PCB. Suppose process P0 is being executed and suddenly an interrupt or system call occurs. The process changes its system state and it saves the state, the list of open files, the list of variables which it has left in the middle, and then it jumps to process P1. So it changes its states whenever an interrupt or system call occurs. It executes, say earlier it was executing process P0, then after interrupt or system call it started executing process P1, and then when P1 was executing, process P0 was in ideal state. Once P0 starts executing, then P1 is in ideal state. So this is CPU switching occurs from process to process. Now this is the diagram of ready queue and various input output devices. This shows the diagram of a ready queue. We can see carefully. In ready queue there is head and tail. Since there is a stack pointer, so there is a concept of ready queue. Queue header contains all the information about PCB. PCB to PCB 7. There are different types of PCBs or number of PCBs are the informations are created whenever the user need it, and at the end they are related, or head and tail is null. So null value is also very important to terminate. Like with stack we have learned that the linked list or list get terminated with the help of null value. So with this diagram, this is you can see carefully, this is one of the important diagram, the ready queue and various input output device queue. Then this is the different diagram about ready queue. The again representation of process scheduling. There is one representation of process scheduling, how the process is scheduling. Ready queue, then it goes to IO queue, from ready queue to CPU. Once the process is allocated to ready queue, then it jumps to it is being allocated CPU. Then from the CPU it goes to, when there is IO request, suppose the process is doing some IO request, then it is shifted to IO queue to perform IO operation. Also, time slice is allocated to each and every process. If the time slice expired, then again the process is shifted to ready queue. Also, fork a child. Creating a new process from an existing process is called fork a child. So once the child process is created, then child process executes. Also, child process after some point or after a certain point of execution, it get jumps or it gets stored in ready queue. Then there is next one is wait for an interrupt. It can happen that the CPU, when a process is taken from ready queue and it is allocated CPU, then an interrupt occurs, and after the interrupt again the process is shifted to ready queue. So these are the representation of different types of request or different types of conditions which occurs in process scheduling. Now schedulers, they are of two type. One is long term scheduler, another is short term scheduler. Long term scheduler is typical of a batch system or a very heavily loaded system. It runs infrequently, such as when one process ends selecting one more to be loaded in from disk in its place, and can afford to take the time to implement intelligent and advanced scheduling algorithms. This is the job of long-term scheduler. Now the next type, we come with to the next type. It is called short-term scheduler. CPU scheduler runs very frequently on the order of 100 millisecond and must very quickly swap one process out of the CPU and another swap into the CPU. It means swap in and swap out occurs rapidly in short term scheduler. Also, there is one more type of scheduler which is not mentioned here, that is called medium term scheduler. When system loads get high, this scheduler will swap one or more process out of the ready queue system for a few seconds. in order to allow smaller, faster jobs to finish up quickly and clear the system. So mainly there are two types of scheduler. One is long term scheduler, another is short term scheduler. Then there is a middle term scheduler. This is the diagrammatic representation of long term scheduler and short term scheduler. Long term scheduler, there is a job pool. It keeps the process from job pool to ready queue, whereas short term scheduler, it directly takes or fetches a jobs from ready queue and allocates to CPU. That is the difference between long term and short term scheduler. The working or the short term scheduler works frequently, whereas long term scheduler, the working is not so frequent. Now this is again the addition of medium term scheduling. I have already explained medium term scheduling. You can find out that there is a ready queue. From ready queue, a process is allocated CPU. Then it can happen that once they are allocated CPU, then also CPU it encounters IO waiting queue. Then input output is occurred and again the process is changed to ready queue. Also, once the ready queue is allocated CPU, it swap out and swap in occurs. So this is the explanation of medium term scheduling. Now schedulers. What are schedulers? Short term scheduler is invoked very frequently. Must be then long term scheduler is invoked very infrequently. Also, the long term scheduler controls the degree of multi-programming, because ultimately it is long term scheduler which chooses how many programs the CPU will execute. Now process can be defined in two ways. One is IO bound process, another is CPU bound process. What is IO bound process? IO bound process spends more time doing input output than computations. Many short CPU bursts. CPU bound process, it spends more time during computations, few very long CPU bursts. This is the characteristics of CPU bound process. Now thanks for watching. Go through what I have taught, process control block and schedulers. Go through them.